This problem right here is an example of a percent change problem where we don't know the original price. In other words, the retail price. I've made a chart here to help us keep track of the percents. We know that the original percent or the original price is always 100% of itself. So that allows us to put 100 in the original price. When we're looking at the dollar side, the only thing that we know is that the new price is $34. In other words, the sale price is $34. If we want to find out what the original price is, I've put N in that spot in the chart, as you just noticed, then we need to write a proportion or an equation that allows us to use that new price of $34 and compare it to find the original price. So we know that the change is 35%, and it's a 35% drop, so I've written a down arrow in the change column, the change row for the percent column. And what that means is the new price, since on the percent side the original is always 100%, we went down 35%, the new price is 65% of the original price. So we are then able to construct a proportion since we know two things in this row that match up with each other. We can use those in our proportion. And since we knew two things in the percent column, 100% and 35%, we were able to also fill in 65%. We now can write a proportion. So for example, we could write the proportion 65 over 100, which says basically 65% of the original amount is what the new price is. So I'll put a label on top, and that's of the original price. So you could imagine if the original price was $100, the sale price, having gone down 35% or $35, would be $65. So on the percent side, the power of it is that we can always start at 100%. But you have to remember that that's the number you are changing or finding a percentage of. So therefore, what we know is that 65 is to 100 as 35 is to n, and we can solve this proportion for n. If you write this proportion as a cross-multiplied equation, you get 65n equals 100 times 34, or 3400. Divide both sides by 65, and you get an answer of 3400 divided by 65, which is approximately $52.31, rounded to the nearest penny. So that tells us that the original price was $52.31 approximately. Of course, this is not exact, and so $34 would have been a rounded answer. However, this allows you to write this proportion in a way that says we can compare the new price to the original price on both the percent side and the dollar side. This must be what you do if you don't have the original price. You must match the row of either new price in the percent side to new price in dollars, or change on percent side to change on dollars, depending on how the information comes to you. Finally, if you were going to write this problem as an equation rather than a proportion, you notice that when you cross multiply, you get 65 times n equals 3400. Well, the equivalent equation is 0.65 or 65% of, so multiply, the original price is $34. And that makes sense if you stop and think about it. The $34 is the result of taking 35% off. So you take 100% and subtract 35%, so you have 65% left. So 65% of the original price is your new price or your sale price. So this is a good example of how you can use either a proportion or an equation to find the original price, since it's challenging to find a percentage of something that you don't know, and this allows you to do it. It's worth noting that if you had a price increase, so for example, if something was going up 35%, so a 35% increase, then your new price would be 135% of your original price. So this is very similar to the previous problem. If you didn't know a price, if you were marking it up to $34, so marked up to $34, that would mean that the original price was a smaller price, not a bigger price, because this isn't a discount, this is an increase. So this would be an increase in the sense that perhaps you bought it from a wholesale supplier and you were marking it up to sell it at the new price so that you could make a profit on it. So if you marked it up to $34, then you would do a similar kind of proportion here, looking for N now, but it would be 135% over 100. So your proportion would be 135 over 100. 135 over 100 equals $34 over N, and you'd be solving now for the original price, which is smaller. So this again allows you to write a proportion by setting up this chart and understanding that the 35% increase means you have 135% of what you started with before. So this is the new price up here, and this is the original price. And if you were writing an equation, 135% written as a decimal is 1.35. So 135% of your original price is your new price, and you could write it like that. And in either case, if you solve this, you get the answer of 34 divided by 1.35, or 3,400 divided by 135, and you get approximately an original price, of $25.19 roughly. And you should be able to go back and check that if you take that as the original price, find 35% of it and add it back on, you should wind up at $34.